My name's Traun Leyden. I'm the Android developer for Couchbase Lite. And just quick raise of hands, who's used Couchbase Lite or looked at the docs at all? OK, so we got Jens, you don't count. Got some familiarity here. So just a quick overview. I'm going to talk about the problem where you store your mobile data. We're going to go through a demo to wake everyone up and see some actual working stuff. And then I'm going to do kind of an architectural overview of Couchbase Lite, and then drill down deeper into the core concepts. There's no code today, not like maybe one line, but it's not a bunch of code slides. So we're just going to keep it high level. So you're writing a mobile app, and you need to figure out where to store your data. It boils down to three choices. You can do it. You can have it remote only, where this is typical. All your data is stored in the cloud, and you talk to it over REST. You can have it local only. This is not very typical, but this is a valid approach. You can just have all your data in SQLite. And then you can have, this is the majority of the cases, you can have your data, you have a copy of your data in the cloud, and you have a copy of your data on the device. So let's look a little bit at the implications of choosing these data locations. So if you choose remote only, you're assuming that the network's always connected. If you choose local only, you don't care about the network ever being connected. And if you choose local and remote, it's kind of a mix and match. Like sometimes it can be connected, sometimes it can be offline. OK, so the implications for your application availability there is if your data is remote only, then your app will only sometimes be available. If your data is local only, your app will always be available irregardless of the network connection. And likewise, if your data is local and remote, your app will also always be available, because if the network isn't available, you just hit the local store. And this is actually a big one. I ran into this in my last startup. We did remote only, and we did some local caching. But when we deployed it into Wi-Fi, the customer Wi-Fi was awful, and so the app would sometimes just be spinning, and it was a highly variable response. And that was kind of what pushed us to switch to what was called TouchDB at the time. It's Couchbase Lite now. And if it's local only, your app's obviously always going to be fast. And if you're local and remote, your app will also always be fast. So what technologies enable these data location choices? So if you're remote only, you can just use REST. It's very typical. If you're local only, it's SQLite. If you're local and remote, put a question mark there. Couchbase Lite is one approach. There's others, which I'm going to walk through real quick. And then narrowing these down in terms of what are sort of usable choices. If you look at local only, that I just kind of X that out because maybe in 1990 that was viable, but today everyone expects sync and share. So we can kind of forget about local only. Remote only, the problem is since the network is, you can't assume always connected, you're going to get these negative effects. So you're pretty much forced into doing some sort of local and remote hybrid. And it's an increasing trend. You see this in all the big major player apps are starting to do this. Parse just created their local storage, part of their API. So I think it's just a very highly increasing trend. So let's say you want to build a Twitter clone. And you've decided, OK, I'm going to store my data local and remote. So what you do is you just pull your remote data from the REST API, and you shove it into SQLite. Since the app will just display data from SQLite, it doesn't matter if you're on the subway. You can go read your tweets, and everything is great. And then for writing, you will need a network connection. And you can kind of do fancy things like, OK, well, if I'm not really online, maybe I'll just queue it up or something like that. Or if I'm online to keep it consistent, what I can do is I won't write it to SQLite until until it actually, I know it made it to the server. And I think a lot of apps are built like this, and people will, they can get pretty far with this. But imagine if you're tasked with building something like an Evernote clone, and you have new challenges. You basically have to be able to add, edit, and delete notes while you're offline. So you're in the subway, something like that, and you still want to be able to like jot a note down that comes to your mind, and you don't want the app to say, sorry, you're offline, you can't do this. The other challenge is, like I mentioned before, even if you're on a bad connection, all these operations should be very quick. And then you also have to worry about conflicts where maybe you've got a user with an iPad and an iPhone, and he's using the same account on both, and he might update the same note on both with different updates. And so what are you going to do in that case? So why is this so hard? So if you look at the writing example, you can't just do that local read-only storage anymore. You need to actually write to SQLite even though you haven't written to the network, into the cloud. So it's now what they call a multi-master system. Then you have to think about deletes. And deletes are a little weird in the sense that you have to propagate deletes. So you actually have to, you can't just delete something and then hope that other things figure it out. You have to almost make a new sort of scheme, like how am I going to propagate deletes? So you kind of have to like make a new record, like, oh, this record was deleted, and then send those records so then everyone knows that that was deleted. And then you have to think about conflicts, and you have to come up with a whole scheme, like what am I going to do if the user edits the same document on two different devices? So you have to come up with some scheme. You could just like throw away one, but it's not something you want to do. So if you have a small, short deadline, you're not going to be a happy camper. Okay, so as you probably predicted, we've already built all this for you. That's why I'm here. And just to give it some concreteness, before I get into the concepts, I want to just like show it off, give you a little demo. So I'm going to be doing a live demo of, oh, don't look at my password. Doing a live demo of an app called To-Do Lite. This is kind of our flagship example app. It uses Couchbase Lite. I'm going to show off the Android version. We also have an iOS version and a PhoneGap version. And they look and feel approximately the same. So before this talk, I logged in with a Facebook login. And I set up this thing in the background, which is a command line app sync gateway. So the architecture is these two devices or emulators are configured. So I can go in the configuration here. So they're configured to talk to my local sync gateway. So, got a reboot there. Let's see. Yeah, things are a little skittish here, so you might have some restarts. So I'm going to show a few things. First, just let me make sure have both these on Wi-Fi. So okay, these are both. That one's connected, and okay, so they're both connected. So I'll add a record on this device, and it immediately syncs to the other device. And now I'll kind of give an offline, or I'll do the full thing. So if I edit, it syncs. If I delete, it syncs. So now I'll go ahead and add another record, and then I will take both devices offline. And I'll make some changes. So on this device, I'll add hello 3. On this device, I'll add hello before. And on this device, I'll delete hello 2. So this is simulating the case where both devices are offline and you've made sort of different changes. And now they both come back into connection and they should sync up so they're essentially in the same state. It's kind of getting glitchy here. Okay. So that worked. So now they're in the same state. The one that I deleted on one got deleted from the other one, and the ones I added synced across, essentially. Okay, so the last thing I want to show is an example of conflicts. So let me just clean up, delete a couple of these. So I'm going to add hello 5 and take them both offline. And on one, I'm going to delete, and the other one I'm going to update the item. So up till now, we haven't actually touched the same record on both. Did I put this offline? Yeah, okay. So on this one, I will delete. And on this one, I will make an edit to it. So it's a very conflicting operation. So the system will have to decide which one it's going to take. Right? Is it going to take the delete, or is it going to take the update? And there's no code in To-Do Lite that is actually has any logic. This is all Couchbase Lite under the hood that's doing its default behavior. And I'll talk about this a little bit more in depth later, but I wanted to show it to you. So put these online and let them sync up. Okay, so you notice what happened is the one I deleted on the left side actually got brought back from the dead. It just kind of bounced back. I deleted it, and then when it synced, it's just oh, I'm back. And the reason that happened was because we have some rules about how to automatically resolve conflicts. And one of the rules is when you have equal length branches of the sort of conflict branches, it will always choose the one that still exists, and that will win over one that has been deleted. And I'll talk a little bit more about the other rules, but I just want to show it to you in action. So can we switch back from the demo to the PowerPoint? Perfect, thanks. Okay. Okay, so this is your typical overview. I didn't put Couchbase Couchbase Server, but that would be kind of behind Sync Gateway. And you'll have mobile nodes. Your app will talk to Couchbase Lite. That has built-in stuff to sync changes to the Sync Gateway and back down to any other Couchbase Lite instances. You can also do peer-to-peer sync. This is not quite as common, but it's extremely interesting for certain use cases. You could think of in a restaurant use case where you didn't even have an internet connection, you might do a peer-to-peer case. There's a lot of kind of fringe cases. I know in Hong Kong right now they're using peer-to-peer to communicate in the crowds because of what's going on over there. So real brief overview of what platforms we support. You hear a lot about iOS and Android, but we also support a desktop OS X or native Java, so that opens up the door to things like running on Raspberry Pi and embedded and so forth. Anywhere Java can run, Couchbase Lite can run. We have native C#, and that's featured on our demo app, which I hope you guys have played with. and it's going to be featured at the Xamarin Conference as well. Right now, it's iOS and Android, but I think the Windows Phone and Windows Desktop is coming soon. We also have PhoneGap and Titanium, and everything's 100% open source, so we've got a very active community. People send pull requests on GitHub quite a lot, and review our code, find our bugs, fix our bugs, that kind of thing. So I think within Couchbase, it's actually one of the most active open source developer communities. Okay, so diving down a little bit further into the sort of surface area, the API that you get from Couchbase Lite, you get document CRUD. You have attachments, which are treated differently than documents. You have views and queries, which are pretty similar to what you'll see on Couchbase. You've got replication, which enables the sync. It's a big part of the code base. And you have things like, you have a pluggable change listener, so you can monitor, it's kind of like the CouchDB changes feed where you're called back every time there's any change in the database. So you can build a lot of cool stuff with that. And then sort of the extended surface area, we have a REST API listener. This is mainly for PhoneGap, and this allows you to talk to Couchbase Lite over a REST API. And that makes sense for PhoneGap because PhoneGap's all JavaScript, and it will kind of talk to it in a sort of HTTP fashion over the local network. Caveat, on iOS, we actually short circuit that local network, so it's a little bit slicker, but on Android, it's really going over the local network within sort of apps on the phone. Like the web view talks to it over the network. So other sort of extended surface area API points. These first three are iOS only, but they're very exciting. There's a model layer, so you can think of it like an ODM. This simplifies your coding a lot. You just create an object, and it handles the marshalling and unmarshalling from JSON, which supports like nested array of objects and object references. You have full text indexing, geoqueries, and this is a very often requested one, database level encryption via SQL Cipher. And last but not least, since ForestDB is all the buzz during this conference, on iOS there is I'll call it experimental branch, but it's pretty solid. I've been testing it a lot, and I think it's not that far away from prime time. And that's the core storage engine, SQLite, has been swapped out for ForestDB, and it's faster. The code base has been simplified, and it's the future of Couchbase Lite. So these are all coming soon to a platform near you. Yeah, it's kind of a big weight on my shoulder and Zach's shoulder, but I'm excited about it. Okay, so digging into CRUD a little bit more. So for documents, it's different from the relational model in the sense that you can have arbitrarily nested structure. For example, if you had a contact, you have a profile with contacts, you wouldn't need to make it a separate contacts object and then do like a foreign key lookup. You can actually just stick those contacts inside the profile. If you need atomicity, like if you want sort of transactional atomicity between fields, you would have to put those fields in the same document. There's no joins, so if you need to look up another doc, you have to do a separate request. So in some ways, there's some involved if you have your existing app. Here's a sample JSON document. There's a couple special fields here. So there's the _ID field. You can provide that when you create the document, or you can just let Couchbase Lite generate a UUID for you. There's this _rev field, which Couchbase Lite uses for internal bookkeeping. You should never really edit that. And then this type field is not, this is just a convention that a lot of people use to sort of group their documents. And you can call it whatever you want, but a lot of people call it type. So when you create a new document, you essentially just pass it if you're on iOS, you pass it an NS dictionary. On Java, you pass it a map, and that can only have sort of like primitives. If you had custom objects in there, you would have to sort of manually serialize those into primitives. And like I mentioned before, it can be arbitrarily nested, which is convenient for representing very complex structures without a lot of work on your part, because you just shove the entire JSON in there. So attachments are used for images and videos. And that, I mean, arbitrary things, but those are the most common things, images and videos. Where the behavior differs is in the sync. So it has an efficient behavior where it will only transfer that attachment if the attachment data has changed. Otherwise, because the attachments are usually very heavyweight, so we've done things so that we minimize the amount of times those attachments are going to get transferred, and it's only when necessary. So if you're sticking your attachment data like as base 64 in your document with Couchbase Lite, you're doing it wrong. A common question we get around attachments is, can you do sync priority? So can you prioritize the sync so that your documents come first and then your attachments come later? Unfortunately, not yet, but I think it's something that it's on our roadmap that we'll eventually support. When you edit documents, it's slightly tricky in the sense that what can happen is you can have a document that was sort of changed under your feet. So you can imagine showing a user a form on a CRM system, and while the user is typing away in the form, a new version of that same document synced from the cloud. And so when the user by the time the user hits save, he's editing, he's going to basically clobber information. So in that case, what would happen is, if your app was correctly written, it would essentially, well, first of all, Couchbase Lite is not going to let you save it. Couchbase Lite will return an error with a 409 error code, and you as the application developer have to decide what to do with that. And typically, what you would do is take it back to the user and say, oh, here are your changes, but new changes have come in. You know, resave it without throwing away those older changes. Deletions are handled by creating a new special revision. And just to clarify, this is not something you have to do at all. This is done for you by Couchbase Lite under the hood. But this is how they work. They create a new revision. This is kind of alluding to what I was talking about earlier, like how do you propagate deletions. So the special tombstone revision will be created on the document, and this will get synced like any other revision. So other devices know that this document should be deleted. When you're talking to Couchbase Lite, if a document has been deleted with a delete revision, when you go ask for that document, it says, I don't have that document. It kind of pretends it's not there, even though internally it knows about that document. There's one this is kind of advanced trick, but it's pretty useful. The tombstone deletion revision, what defines that is just to have a special _delete field. So if you use Couchbase Lite by default, it will just, the new revision will only have the _delete field. However, you can, if you want to keep other fields around, you can just add an _delete field and keep other fields around. So you kind of, you have this sort of ability to, let's say, bring that deleted revision back to the dead, back from the dead with those fields. Or if you're debugging, sometimes it's useful to see what that document looked like before it got deleted. And since we use these tombstone revisions, there's a compaction process which you have to periodically call this on your database to compact it, which will essentially garbage collect and clean up the old deleted documents. The sort of special operations of CRUD that you might not see unless you dive deep in the API, we have this concept of document purging. So if you want to delete a document, but you only want to delete it from that local device, you don't want to delete it from the system per se, but you need to free up some space locally, you can purge the document, and that act won't sync to any other devices or to the cloud. It will just purge it locally. There's also something called local documents, which is a non-synced document. So it's something like you could use this in place of a lot of people will use like the shared preferences that iOS or Android provides. You can just use a local document if you're using Couchbase Lite to store things like the user who last logged in on this device. It's useful for stuffing information. Let me come back to, I'll loop back around. I'm going to leave a bunch of time for questions. Okay, so that was CRUD. Let me do a quick overview of conflicts. So we already saw this, so I'm just going to walk through kind of like what goes on under the hood in conflicts. So you start out where you'll have, let's say, these two devices will have the same sort of revision history, Rev 134, Rev 263, and same on this side. And so they're in perfect sync. And then let's say you take these devices offline and you create conflicting, like you create a new Rev 3 on both. And they have different digests here because they're different changes, and I've color-coded them, so it's like the green one and the blue one. And then when they both go back online, Couchbase Lite will deterministically pick a winning revision, and it's deterministic. By deterministic, I mean there's no communication involved here. It's just using an algorithm. They're both using the same algorithm, so they're both going to do the exact same thing. And in this case, they both choose the blue rev as the winner. And this is exactly what happened in the demo I showed you. And the rules for choosing the winner are essentially, well, one of the rules which I mentioned is the longest sort of branch will win. So these are equal length branches, just one. But if this branch, the blue branch, had, let's say, two or three, it would have been chosen for the winner because of that. Also, if one is a deletion branch, it will lose by default. And then if it's kind of like a tie, if those other things end up in a tie, it will compare the digests, just like a lexicographic comparison of the digest, and pick the winner based on that. And since it will be doing the same comparison, it's going to happen. The same thing is going to happen on both sides. So you might be wondering, like, okay, how can I kind of insert my own conflict resolution logic? You can't intercept it, but you can, after the fact, you can go patch it up. So if you don't like the conflict resolution that was chosen for you, you can go change it by deleting the branch you don't want, and you might even have some application-specific merging. So you would merge some values into the winning branch. And this is something we don't do in our to-do like demo app, but it's something we should probably add, because This is getting into one of the more complex sides of Couchbase Lite. But it comes up as a common question, so I wanted to give you guys a taste of it. So views and queries is how you get data out of Couchbase Lite. It's lower level than you would find in SQL. Bob mentioned that we're going to be getting nickel in Couchbase Lite, which is true. The deadline he promised, I don't know if that's true. You don't have joins. I mentioned that before. You write a map reduce. The map function is required. The reduce is optional, and reduce is used for usually for aggregating or counting data, analytic kind of stuff. Typically in an app, your views will map to like UI tables. So the list of to-do items we were looking at in the demo, there's a view that generates that list. That's pretty typical. And you define your map function with a native callback function. Okay, so this I'm going to drill down into the most simple view you could have. So if you have these documents, just some users, they each have an ID and they have an age. And you want a view that's going to be showing only the users that are between 20 and 30 years old. So Mary, age 52, should not be included. And Bill, age 15, should also not be included. So how would you do that with a Couchbase view? So this is the only code in the presentation, and it's sort of JavaScript-y, Python-y. It's just pseudocode. So you provide a map function. Like I said, on Couchbase Lite Android, this will be in Java syntax, and likewise on Couchbase Lite iOS, it will be in Objective-C. So here you're going to, this is the value you're going to be emitting, like the name with the age in parentheses. And as the key, you'll be emitting the age. And then you just call emit. So it generates this view index. And so it's going to sort them by default by the key, the sort of natural sort order of the int. And you've got 15, 20 for all their ages. So the next thing you want to do is query the view. And on the query, you need to provide, the queries, a lot of queries, they're just kind of, the view's already there, it's sorted. And the query, you're just like going in and just getting a chunk. You're just saying, give me that chunk. And you define that chunk that you're getting by the start key and the end key. So here, we create a query. We set the start key to 20. We set the end key to 30. And then so we're going to get this chunk of the view only. And that'll be the view results. So just kind of some random tidbits about views. It's another big topic like conflicts. I can't, there's no way I can cover them. There's a lot of subtleties, and you can do some really complicated things with them. Pretty advanced things, but I'll just try to skim the high level to give you a taste. So the key that I emitted was just a single value, their age in that case, but you can actually emit an array key. You can group queries, and you can specify group levels. You can, there's a subclass of query called a live query, which will essentially the Couchbase Lite will be constantly looking at that query, and it will be calling back your code every time there's new results. So on to-do Lite example apps, we actually use that. So for example, on the iOS, it binds this table view with a live query, and Couchbase Lite handles all the plumbing for you, and it will call update rows on that table. So it eliminates a lot of the work that you have to do as a developer. One thing that a lot of users fall into this pitfall is that the map function must be like a kind of a mathematical function where It must always produce the same output given the same input. And if you do things that, let's say, depend on the current time inside that function, you run into problems. So a lot of the support questions we get are related to people getting stuck on this gotcha. And then a super advanced tip, which you can just keep in the back of your mind, for a given document, you can actually emit more than one row into the index. And so that allows you to do some pretty cool stuff. I'm not going to get into that either. OK, so we're almost to the end. This last part's really light. Just wanted to do a quick overview of some of the properties of replications. Then we can open it for some questions. So wanted to mention that the push and the pull replication are independent. So in this example, you have on this device, it's doing push and pull. But let's say on this device, it's just like a manager. He doesn't want to edit information. He just wants to see what's going on in the database. It can just set up a pull replication only. I didn't show it in a slide, but you can have multiple replications running against the same sync gateway. You could have multiple replications running against different sync gateways. Not really typical examples, but it's all possible if you want to kind of go crazy. There's two types of replications. There's a one-shot replication and a continuous replication. So the continuous is probably the more commonly used because it's like fire and forget. And this is what To-Do Lite does. When the app starts, you just fire off a continuous push and a continuous pull. They run in the background, and you don't really think about it. It just runs, and it works. I will say that building a UI and kind of indicating to the user what's going on in the background is kind of trickier with the continuous replication. And I think going forward, we're going to kind of supply things that help people build a UI for that. I think everyone's just reinventing the wheel. Like on To-Do Lite, we just have a little spinny. One-shot replications are, as they sound, they just run. They run to completion, and then they stop. So a good typical use case, I mean, it's easier to like interact with the user this way because you can just have a blocking spinny if you wanted to while it was pulling data. And then it's very clear to the user that there is a replication running and his data is in transit. It hasn't actually made it up to the cloud. And I think this is less common, but I don't really know. In our example apps, it's definitely less common. And with the replications, you have a callback API you're notified of their lifecycle changes. So it's mainly relevant for, let's say, a continuous replication where you want to know when the replication, let's say if it's pushing changes or if it's idle. So if it's pushing changes, you might want to show a UI indicator. And so you just register a callback, and you'll be notified with like a state and some statistics about the replication. How do they work? How do they talk to the server? So they use, by default, on iOS, it will use WebSockets, which is really efficient. And it will open a WebSocket to the sync gateway changes feed, and those new changes will flow down that WebSocket. On Android and .NET, we use HTTP long pull. And this is a real big topic. I'm not going to go deep into, but you should go, if you're interested in this at all, you should go to Andy's session on the sync gateway at 420. So if you want to just replicate a slice of the database rather than the whole database, which is very common, and that's what happens on the To-Do Lite demo app. You only get data that you've created or that's been shared with you. Then you need to use channels. As far as like running the background on iOS, I think you get like 30 seconds and then of replication running in the background when the app is backgrounded. And then if you need to wake it up, as of iOS 7, you can send it background push notifications or a scheduled background task. On Android, it essentially just runs in the background as long as it's not in deep sleep. So resources, this slides deck's going to be available online, so I'm not going to go over this, but I try to group all the most important resources. Grab a photo if you want to. And actually, I think the next one is questions, so I'll leave it on this. So you had the first question, so you can start off.
So there's a purge, so it's not possible to bring back. I purge something.
If you purge something, what was the question?
Can I bring it back?
So the question is, if I purge something, can I bring it back? So not that I'm aware of. Actually, let me take that back. So when you purge something, if it had synced to the cloud, let's say, you'll actually have another copy on the cloud. And by purging it on the device, you won't touch that copy in the cloud. So you won't lose that data. But if you had created a record while it was offline, let's say, and that record or that document had never synced up to the cloud or any other device, and then you purge it, it's irretrievably lost.
Yeah,
we don't save it anywhere.
It's on the cloud already, and I purge locally.
Yeah.
So it's not possible to pull it back.
I'll have to get back to you on how you would pull back a purge document. Yeah, let's catch up. I don't know off the top of my head. Yeah.
Traun.
Yeah. Hey.
Again in the cloud.
What's that?
Edit it again in the cloud.
That will pull it back down? Okay, that's your answer.
But I need to do that locally on a mobile device. So on mobile, I cannot put it back. I cannot edit, right? I need to put it back first.
Yeah, if you thought that you're going to need it again, you probably wouldn't want to purge it. I don't have a good answer there, but we can catch up later because I was worried that I was going to get stumped, and I think you number one, stumped me. Yeah.
What's the other ways to do encryption of database level encryption on Android now, and how's ForceDB going to affect that in the future?
Okay, so the question is there a way to do database level encryption on Android today? And then once we switch over to ForceDB, what is the encryption story on all platforms? So the first question is unfortunately no. It's that, I think, in full text indexing are like the two highest priorities on our roadmap. We've got a lot of people asking for that, and we've got a lot of people that are like just blocked on not being able to use us because of that. As far as ForceDB, unfortunately Jens just bailed a few minutes ago. I don't know, Jessica, if you know anything about that, but. Okay, I think you had a question.
Usually mobile phones will be having like 16 GB, 32 GB kind of thing. So application, if it is continuous syncing, so suppose I have on cloud, I have 1 TB images or that.
Yeah.
So if continuous syncs, then I have only 16 GB. So what will happen?
Okay, so the question is, you have a 1 terabyte database in the cloud, and your mobile device has 16 or 32 gigs of storage. How are you going to sync the whole database? So you don't want to sync the whole database. We have a concept called channels. So in the To-Do Lite app I showed you, it actually uses channels. So our To-Do Lite database that we have in the cloud is not that big, but it's pretty big. And when I log in and do a sync, it syncs only my data and data that's shared with me.
Yeah, only my data only.
Yeah.
Having 1 TB.
Yeah, but with the channels, you can partition your database and slice it up as arbitrarily as you want. So that's one example of using channels, but you can go crazy in how you want to slice up your database. So you only get the data, the smallest subset of data that you need on the mobile device, and everything else stays in the cloud. So you should go to Andy's session at 4:20 in Sync Gateway, because he's going to talk in depth about channels and how to define the channel function. because that's more on the sync gateway side. And in the Couchbase Lite, you just tell it which channels, and it will pull those. I'm out of time, but thanks a lot for watching.